Collisions are the major application of momentum, so this is a video that will work through the idea of collisions. The big thing that we have with collisions is this. We have a system of maybe two objects, and these objects are moving. Maybe this one has a mass 1, v1, this one has a mass 2, and let's have it move toward it. v2. This is kind of my picture of before. After the collision, maybe these two things stick together. That's one option for what can happen. We'll talk through the different options as separate examples, but maybe these two stick together and they move to the right. V final. This is my after. I can find my total momentum before, and I'm going to have to figure out a direction I want to call positive. Now this is a one-dimensional collision, so I only need to worry about the one. I don't have to do like an X and a Y. If I made positive to the right in the beginning, I have to make positive to the right afterwards. And what I'm saying is that my total momentum before the collision is equal to my total momentum after the collision. That's really the entire idea of what I'm doing with collisions. Now over here, what I would have an M1v1 and I would have an M2v2, but because mass 2 is moving to the left, this guy's going to pick up a minus sign. Over here, these are stuck together, so I'm going to get the total mass times v final. And then if I'm solving for my final speed, I'm just setting these things equal to each other and solving for my missing variable. That's really the whole idea of collisions. That's the only thing that I really want to be able to do with it.